Okay, so this is the second part of the 7.4 lesson for my applied math grade 11s. And we are on this page here. If you have the pages numbered, it's page number 14. And this is actually kind of just a summary page. So in the 3 lessons we've done up to 7.4, we have now covered 3 different forms of a quadratic equation. We already have this in our notes somewhere else, so we'll just do this one really quickly. The vertex form of an equation is, of course, this guy, where you look at the equation and you can see right away what the vertex is, because there's this perfect square. There's this square of a binomial here, and the square of the binomial, inside of it is the vertex, where the x coordinate of the vertex is the number h, so whatever number is there, and the y coordinate of the vertex is k. So for example, if you had something like y equals x minus 2 squared plus 3, you would know that you had, make a quick sketch here, a parabola that has a vertex 2 to the right and 3 up. And remember that a number tells you something too. It tells you if a is positive, that the parabola goes up. If a is negative, the parabola goes down. And if a is not 1, then the parabola is either wider or narrower than an ordinary parabola, where a is 1. What I notice about a, this is kind of cool, because now let's do a quick summary. So in this space here, we'll just do a summary. We have 3 forms of a quadratic equation. Oops, I hit the button while I was trying to write. We have 3 forms of a quadratic equation. And the first form we saw was standard form. And notice once again, it has a. And the one we just talked about, which we did second, was vertex form, which is this guy. And now, in the first part of this lesson, our third form is what we call factored form, which looks like this.
When you say solve this equation, what do you want us to do?
That's an excellent question. If a question says solve a quadratic equation, that means figure out what x is. Find the x-intercepts. So of the 3 forms, which of the forms is the most useful if what you want to do is solve? The factored form, because it has the x-intercepts right here. It's this number and that number. But if you want to make a graph, which of the 3 forms is the most useful? Probably the vertex, because you know where the graph stops and turns around right here, h and k. And if the equation's a formula you have to work with, like this quadratic equation represents how high a ball is going to bounce or something like that, then you're probably better off with standard, because it's the easiest to plug numbers into. You don't have a bracket to deal with. And the standard form does tell you one thing about the graph. It tells you where the y-intercept is, because that's the c number. Notice what they all have in common. They'll have a. They all tell you whether the parabola is up or down, and whether it's skinny or wide or normal. And again, normal means a is 1. So they all have their pros. They all have things that make them work. If you were in the pre-calc course, you'd learn how to go, especially from standard to vertex. It's a pretty complicated process that we don't do algebraically here. I can show it to you, but we don't have to do it in our notes. Okay, but we should be able to, at this point, use technology and make a graph with any one of those forms, especially if we have technology to help us. So let's see. Let's do our first example here. Back to vertex form. So let's see if we could do it without touching Desmos or the TI first.
Are we going to get a formula sheet for this time?
I just handed you a formula sheet. What's on it? Those of you watching this at home, the question was, Do we get a formula sheet that says these three things? Kind of. Look at your formula sheet. I think they're all on there. As well as one very odd-looking thing, which just happens to be on the board because my other class needed it for their test. That's our next lesson. That's called the quadratic formula. That's what you were trying to ask me yesterday, right? That's the thing you meant? That's our next lesson. We'll save that for next week. All right, so let's get back to these two examples, and then I'll give you some time to work on your homework. So graph each of the following quadratic functions. This one's a vertex form, right? So it tells me that my vertex is 4 and -1. Hey, how come the 1 gets to keep its negative, but the 4 doesn't? It's not because it's squared. That's a good guess, but it's not because it's squared. It's because this is the formula. Oh, and I forgot the A. Hang on, let me put that in there. It's because this is x minus h. So whatever h's value is, it gets minused in the formula. So if I see -4, h is 4. If I had seen +4, which I'm going to see in the plus in the next one, this vertex is -3, 8.
Why? How?
Because look at the formula. H is being subtracted. So the only way you can subtract a number and get a positive is if the thing you subtracted was a negative. Think of this if you like. Think. It's like, this is math class. I didn't come here to think. Well, unfortunately, some formulas need thinking. Think that this is -2 times x minus -3 squared plus 8. Get it? Minus a negative means that's why it's a plus. So there's like a little opposite rule you have to look at when you're doing the vertex form. Let me make this a little smaller. There we go. Okay, let's fill out the rest of it. What does the vertex tell you about the axis of symmetry? The x value has to be the same because the axis of symmetry has to pass through the vertex. So that kind of tells you for sure what those are. Okay. Now the parts that are tough. Does the vertex form tell you the x-intercepts? Well, the factored form does. It's those two numbers there. Does it tell you the y-intercept? No, the standard form does. It's right there. So we have two choices to find the x-intercepts and the y-intercepts. We can use technology or we can use algebra. I'm going to go through them algebraically and then we'll use the technology to see if we did it right. Question?
Why is the x value -3 instead of 3?
Because again, look at the formula. It's x minus h. So when it says x minus 4, h must be 4. But when it says x plus 3, hey, where did that minus go? It must have got canceled by the fact that the number that h is a negative. Right? That's the only way to make a negative go away is to minus that negative. Does that help? All right. What do you know about the x-intercepts? What do you know about every point that might possibly hit this x-axis line? Y is 0. That is correct. So let's take this equation. Now, you might want to do this on a piece of separate paper. Is the back of this a blank page? I don't remember now. Yeah, so oh, no, it's not. Oh, yeah, the back of this was a blank page, wasn't it? Yeah, maybe go over to that blank page, and let's do some algebra. So we have the equation y equals x minus 4 all squared minus 1, and we'd like to find the x-intercepts. What are they? Well, x-intercepts happen when y is equal to 0. So I'm going to take my equation, and I'm going to plug in y is 0. This is probably the most complicated algebra we'll make you do in this course. I have to isolate that x. Tell me a story about what's happening to x. Once upon a time, there was an x. It got what? What's the first thing that happens to x? Look at the equation. It gets minused by 4. You take away 4. What happens to x next? It gets squared. And then finally, it gets subtracted by 1. Undo those steps. But you have to undo them in the opposite order. What was the last thing that happened to him? -1. So that's the first thing you have to undo. How do you undo -1? You add 1 to both sides of the equation. So that's going to be 1 equals x minus 4 squared. How do you undo squared? Right. The opposite of squaring is square rooting. Now, here's the thing, though. Let me give you a, don't write this down. Don't write this part down. Let me give you a simpler example of where you have to square root to get an answer, right? If I square root x squared, I get x. What's the answer on the other side? Now, you're probably thinking, well, it's 4. 4 times 4 is 16, but think a number times itself is 16. Isn't there two numbers that give you that answer? 4 times 4 gives you 16, but so does negative 4 times negative 4, doesn't it? So when you square root both sides of an equation, there's a rule here. You have to put a plus or minus on the answer before you can say it. So I'm getting two answers here when I go back to this step. I'm going to square root both sides of the equation, but that's going to give me plus or minus the square root of 1. And at this point, I have undone squaring on the other side, right? No, there's no, y was 0, so I replaced y with 0. Okay, and I'm going to erase this because it's going to be in my way in a minute. Okay, so there we go. There's our first step, or our second step. First step, get rid of the minus 1. Second step, get rid of the squared. But doing that created two different equations. It created the equation, well, what's the square root of 1? What number times itself is 1? 1. So this is either positive 1 or it's negative 1.
That's x1, that's x2.
And notice, yeah, doesn't it make sense that some parabolas have two x-intercepts? Yeah, it does, because it crosses the x-axis twice. So it makes sense that our algebra gives us two answers. So this is my first x-intercept. Okay, what's the last step? How do you undo minus 4? I'm going to add 4 to both sides. Do you need me to write it like I did here? I will. I don't need you to show me that. You don't have to. What am I, in grade 8? I got to show that? No, you don't have to if you don't want to.
Why did you transfer the positive negative from 4 to 1?
Well, the positive or negative could really be added to both sides. But okay, I want you to think about this logically. If I square root both sides and I say, okay, this side could be plus or minus, and this side could be plus or minus, which would you choose? It wouldn't matter. You'd still either get one side. If they were both negative, they'd cancel and be positive anyway. So you have really only two choices, a plus 1 or a minus 1. So that's why we just go with the two choices. Okay, what is 1 plus 4? 5. And what's negative 1 plus 4? 3. So we've done it. We've found our x-intercepts. 5 and 3. All right. Hopefully this logic makes sense to you. If the x-intercepts happen when y is 0, when does the y-intercept happen? Right, when x is 0. You would hit the you'd hit the y-axis when your x value is 0. And that's actually easier. I saved the easier one for last. Replace this x with a 0, and I don't even really call this algebra at this point because I don't have to do any opposite operations to isolate a variable. To me, that's just arithmetic. What's 0 minus 4?
0. Oh, wait, negative 4.
How about negative 4? Yeah, that's a better answer. I like that one better. But notice I still haven't dealt with this bracket because I have to square whatever's inside, and whatever's inside is a negative. What's negative 4 times negative 4?
16.
Positive 16, and then 16 minus 1 is 15. And I don't think that's even going to fit on this graph, is it? Yeah. Okay, but that's fine. So it's above the graph. No problem. We still have it. It's in our chart. It's 15. Can I go back? Okay, I'm sorry. Am I going too fast? I'll slow down a bit for you. So there we go. Some people says, oh, that's a lot of algebra. I don't even think of the right side as algebra. To me, that's just arithmetic. I plugged the number into the equation. I didn't have to rearrange the equation. I didn't have to pull algebra moves like I did on the left. And now I'm ready to fill out the rest of my chart. Oops. Okay, are we good now? Can I move over back to the chart? Okay, back on the chart. How do I know about the domain? Oh yeah, easiest half mark ever in the whole world. And if you like the interval notation better, feel free to use that. For the range though, which number that's already in the chart tells me the range?
4.
No, it's not the 4.
Negative 1.
It's the -1, because -1's the vertex. It can't either go above or below that. Which one is it? It can't go below that, because -1 and 4, we better start putting things down. 4 over and 1 down. There's the vertex. And the a value here is a +1. So this thing is a smiley parabola. It goes up, which means my range is y is greater than or equal to -1. If you want to write that the other way, you can go, I go from -1, comma, to infinity, round bracket. How do I know that it goes bigger than? Only because, again, I know that this parabola goes up. So there's no number that can be smaller than -1, right? Range is what are all the possible y values? And in this case, y can never go below -1. So y is bigger than or equal to -1. Okay, and let's put the other stuff on here. We have an axis of symmetry at 4 here. I'm going to make this bigger so you can see my graph better. I have an axis of symmetry at -4. I have a, let's see, what do I have? I have a X-intercept of 3 and 5. And I have a Y-intercept of 15, which is way the heck up there. But again, I've shown you this trick before. If you want more points, you can count them. A is 1. So this is a normal shaped parabola. What do normal parabolas do? If you start at the vertex and move 1 over, you move 1 up. Well, I already have that point. What if you move 2 over? You should square that. Move up 4. 1, 2, 3, 4. So that would be a point. What if you moved over 3? 9. So that's 4. So 5, 6, 7, 8, 9. And that's about all I'm going to have room for, because the next jump would be too high to put on the grid. So there's my graph. I know that in a regular y equals 1x squared parabola, you don't have to write this down, just think about this. I know that the pattern is always when you start at 0, 0, if you move over 1, you go up 1. If you move over 2, you go up 4. If you move over 3, you go up 9. Where are these numbers coming from? I am squaring them. So I started at my vertex, and if I go 1 to the right, I go up 1. If I go 2 to the right, I go up 4. If I go 3 to the right, I go up 9. And I know the points on the other side of the axis of symmetry have to be symmetrical. In other words, it's a mirror image, right? Parabolas have to be mirror images through the middle. And this thing curves up, and then it wouldn't cross the y-axis till, what did we say it was again? 15. So that's a little past my grid. So that's it. Okay. The next one, it has one thing that makes it just slightly harder. What is it? The A isn't 1. So I got to think about that. So let's roll through that one. Okay, so the first thing is we're in vertex form. So we already know the vertex, which told us the axis of symmetry. But now when I do the X-intercepts, okay, so I'm gonna need some scrap paper again. Hopefully you still have room on that blank page. If not, take out a piece of loose leaf and let's roll through the algebra on this one. It's y equals -2 times x plus 3 squared plus 8. So on my last piece of algebra, there were, what was my story on x? X had 3 things happen to it. It got minused by 4, it got squared, and then it got minused by 1. Now I got a 4th thing happening to my x. What is the order? It's being added to 3, then what? Right, BEDMAS says exponents happen before multiply, so it's being squared, then it's being multiplied by -2, then it's being added to 8. So I have one more step to undo. Step 1, I'm still going to, well, step 1, if I'm finding, show your work. The y, oh, sorry, y. I meant to say x. The x-intercept happens when y is 0. So let's make y 0. And okay, here comes the algebra. What's the first thing I said we got to get rid of? Death to the 8. Okay, I'm not going to show it this time. What happens to the 8? It gets minused from both sides. 0 minus 8 is -8. Okay, what happens to x first? getting squared or getting times by -2? The square happens first, so I undo it last. I have to undo the -2 first. What happens when you divide -8 by -2? First of all, do you know why I'm dividing? Because that's the opposite of multiplying. So what's -8 divided by -2? 4.
Wait, why aren't we just putting it to the other side?
I did put it to the other side. It became a divide on the other side. -8 divided by -2 is 4.
I mean, why are we dividing instead of putting it on the other side?
Well, dividing is putting it on the other side. Algebra is doing opposite operations to both sides of an equation. You can't do something to one side of an equation and not the other. That's not how algebra works. If the way you've always thought about algebra is, I pick up this 8 and move it to the other side and it magically becomes its opposite, good for you, but that's not really what you're doing. You're minusing 8 from both sides. And in this case, if that -2 moves over and becomes a divide, great. The way I think about it and the way algebra actually works is you're dividing both sides by -2.
I see.
Question?
Is this kind of like the bedmass thing that happens?
It's the opposite of bedmass if you want to think of it that way, right? Okay. Now we've hit the step where we have to cancel squared. So I have plus or minus the square root of 4 equals x plus 3, right? And again, if you like to think of it as this squared moved to the other side and became a square root, there's nothing wrong with that. But keep in mind that's not really how algebra behaves. Now, at this point I realize I have two equations. One where I have the positive square root of 4 and one where I have the negative square root of 4. What is the square root of 4? 2. So I have either positive 2 on this side or I have -2 on this side. And now we just minus 3 from both sides. So this x is -1 and this x is -5. I've found my x-intercepts. Okay, go back to the chart and put them in. To the right, there's nothing up there except the last example. I'll get back to it in a minute. Okay, so let's go back to our chart and put those numbers down. -1 and -5. All right, how did I find the y-intercept again?
If you put x as 0.
The y-intercept happens when I put the x as 0. So y equals -2 times 0 plus 3 squared plus 8. That's just arithmetic, right? The thing I'm solving for is already isolated. I don't have to do any algebra, I just have to do bedmass. So 0 plus 3 is 3. And then you have to know bedmass. What do I do first? Times 3 by -2 or square it? Square, doesn't exponent come before multiply in bedmass? Right. So this is actually -2 times 9. Now, what's -2 times 9? -18? Plus 8? Hey, this one will just fit on our grid. Oh, I lost my negative.
Exactly fits.
Exactly, just fits. -10. So, I'll give you a sec to catch up to me there. And -10 is my answer. So here we go. Let's go over to the chart. Okay, so on my chart, y-intercept's -10. Okay, let's put everything down before we do domain and range. Vertex is 3 to the left and 8 up. The axis of symmetry goes right through it. Oh, I'm not very good at drawing a perfectly straight dotted line. Never have been. Okay, and then my x-intercepts happen at -1 and -5. My y-intercept, yay, actually makes the screen this time. What do you notice about this parabola? Two things that are different about the one above it. It's upside down, and it's skinnier because there's a 2 in front of it. So there we go. If you wanted more points, you could get them. I'm not saying you have to. These 4 points are plenty to make a graph. I can see what's going on. But here, how about I know that there's a mirror image of this -10 over here? And how about I know that, again, a normal parabola goes 1 over from the vertex and then 1 in the y direction. This one will go 2 times that. So 1 over, 2 down. 1 over, 2 down. 2 over would go 8 down, but I kind of already know those 2 points. So I'm good. I think I graph from here. Try not to make it too pointy. It is still a curve. Oh, I should use black. Make a nice curve. It's not a point. Oh, I missed that one. Make the dot bigger when you miss it. There we go. That's the big dot theorem.
Wait, so how is it like 1/2 again?
Well, again, a normal parabola. A normal parabola. Let's go back here and make, okay, people need to look at that probably. Don't write this down. A normal parabola, where it's just 1x squared, does this. 0, 0, 1, 1, 2, 4, 3, 9. But if this was y equals 2x squared, what do the points do? 0 is still 0, but when you go 1 for the x, 1 times itself is still 1, but times 2 is 2. 2 squared is 4, but when you times it by 2, you get 8. 3 squared is 9, but when you times it by 2, you get 18. What do you notice about the difference between these numbers and these numbers? The ones down here are twice as big as the ones up there. So the graph is heading up, or in this case down, twice as fast. That's what makes it skinny. All right, go back to the chart. Yeah, we're not done the chart anyway.
Stay there. Stay there.
Right here?
Yeah.
Like that?
Exactly.
Okay. All right, I'll give you a sec to catch up to me. I haven't done attendance yet. I'll do that while you're doing that. My IDSB logged off for some reason.
Oh, it's big.
It's me. Mm-hmm. And then slot 3. Oh, did anybody bring stuff for our hamper? I bought a bunch of stuff. Did anybody remember to do that?
I couldn't.
Couldn't? Okay, that's fine. Okay, so who are we missing? We're missing 1, 2 people here.
Stop at 8:30. Shut up.
That's all we're missing, right?
Oh, no. 1:30.
Okay. All right. Okay. Everybody good on this page? Okay, let's finish off the chart. What have I not done yet? Oh yeah, I haven't done domain and range. Okay, domain. You could make a little stamp of this, just stamp. X, oops, hang on. That's a funny looking X. X is an element of reals. Or again, if you prefer the interval notation, you're going from negative infinity to infinity. But what's the range? Careful, it's different from the last time.
Greater? That means less than.
This time it's a less than, right? Because it goes down forever, not up forever. So y is less than or equal to 8. And if you like interval notation better, careful, it's backwards this time. You go down to negative infinity. You always have to put the smallest number on the left. And you go up to 8, square bracket. Okay, question? No, as long as you've got the right. I mean, look at that. That's not one of my better efforts. The question was, would you lose mark if your parabola was a little pointy? No, I don't think so. No, I'm looking that you have these points in the right place and that you have the right direction. That's what we're looking for. Okay. All right. That's all I wanted to do with you. I'm going to let you have time to work on the homework. I was going to show you one more thing. Again, how would I let technology help me if I had the choice to do this with technology? Well, with technology, I can literally just type this in the way that it shows. So where's my cursor? Oh, there you are. Okay, so let's go to Desmos real quick. There it is. Okay, so I'm typing in the first one. And I type that in as, here, I'll type it the way you have to type it if you're using your phone. Using this keypad here, y equals, open a bracket, x minus 4, close bracket. The a squared button means square whatever you have on the screen, and then minus 1. And notice it gives you all the points you want, right? There's the vertex, there's the X-Intercepts, and you can even go up, and it should give you the Y-Intercept, which didn't fit on our grid when we drew it, but there it is at 15. Okay, and then if you want, it's like, oh, I messed up my screen. There should be a little button that shows home, and that just goes back to where the screen started. Okay, so there's the first one. The second one is y equals. Now, Desmos doesn't have a different button for minus and negative. So you can just hit minus 2, open bracket, x, plus 3, close bracket squared, and then plus 8. And then, as you can see, once again, vertex, you just click on it and it'll tell it to you. X-intercept, other X-intercept, Y-intercept. What? Not all the time. There will be at least a couple marks where I want to see if you can do this without the technology help. But certainly when we get to the problem-solving part of the questions, I don't want you to trip up in just making the graph. I want to see if you can read the graph and answer the problem from the graph. So we let technology help you with that. Also, you'll notice these worked out, so all these points are just nice. What if instead of, let me go back to the first one. What if instead of this being a 1, what if it was a 2? What if it was -2? Look what happens to the X-intercepts. Ew. Ew. So guess what? I would have gotten really nasty square roots of numbers that aren't perfect squares, and without a calculator, I won't do that to you. So that's actually a good thing to know when you're writing my test, because it's like, oh crap, I just tried to square root a number and it's not a perfect square. You know what that's telling you? You've done something wrong. Go back and fix it. Anything that involves having ugly little decimals in the graph will be on the calculator portion of your test. Okay? Now, having said that, it's not a big deal to somebody who's used to working with decimals a lot. All that would have been different over here, let's see, where was the algebra for that? Right here. If this had been a 2 instead of a 1, big deal, this is a decimal. Right? If you have a regular calculator, not even a graphing one, you should be able to work with decimals. So it's not a big deal, but I won't do that to you on this type of question. Okay? All right, the other thing I was going to show you is, of course, the TI. I do have a couple people still rocking their TIs. So here comes the TI. Come on, bunny. There you are. All right, so go and make sure stat plot's off. Yeah, all the stat plots are off. Make sure that any old equations aren't there, and then you type it in. Now, careful. I'll just do the second one. Careful. The graphing calculator says there's a difference between minus and subtract. So I want -2, open a bracket, x plus 3, close bracket, squared is this button here, x squared, plus 8. And then when you hit graph, assuming you have the regular window, there it is. Now, how do I find all the points? Remember, we've seen this before. Go to calc, which is second function trace. And if you want the y-intercept, you do number 1 and hit a value when x is 0. And then there's my y-intercept of -10. If I want the x-intercepts, I go calc, and the x-intercepts are called zeros. So click a 2, and then you have to put the cursor. Now the cursor is going to be where I left it before. I'm going to have to move it a long way. I'm going to move it all the way over. Can you see the cursor moving, guys? Move the cursor to this side. That's my left bound. Hit enter. Move it past the x-intercept I'm looking for. Hit enter. It's going to guess. The guess is always wrong. And there it is, -5. Okay, now I have to find the other one. So calculate the other x-intercept. Go back to 2. But this time move the cursor until I'm just to the left of the other point. There we go. And then hit enter and go just to the right of it. And then hit enter. Again, the guess is always wrong. And it's -1. And then one last thing. How do I find the vertex? Calc. Which of these things is the vertex in this case? It's a maximum, so I have to hit 4. And then move the vertex, or move the, sorry, move the cursor to the left of the vertex, hit enter. Move it to the right of the vertex, hit enter. And there it is. And again, this thing counts in pixels, so it's sometimes off by a very small decimal. You'd round that to -3,8, which is what we got when we did it right there. So there it is. There's the technology way to do it. That's a lot less work than all the algebra, isn't it? That's why we don't make you do the algebra much. But we will give you at least 1, maybe 2, like this on the test, where we have to see if you can do this without the technology. But just like these questions, the numbers will work out nice for you. You shouldn't get ugly decimals. Okay? So there we go. You have an assignment here that you can work on. Go to the blog. And that's not you. Hold on. Wait a minute. This is old stuff. This is not the right place. There we go. That's you. Slot 3, page 391, 1 to 5, 8, 9, 11, and 13. Okay, so that's the assignment you should be working on. And we'll see what happens after that. You know what I'm going to add to this for homework? I'm going to type it on the blog in a minute. Here's something else I want you to do for homework this weekend. See if you can get your Teams account working. Just in case. Just in case. Okay, I'm going to stop the video here.